So in the video notes for Standard 5, we studied the average rate of change. And we did that for various functions where we wanted to find the average rate of change over a specific interval. But the x values that made up the endpoints of that interval were always numbers, right? So here we're going to leave them arbitrary as variables. So we have this one, we want to find the average rate of change of this function between a and a plus h. So instead of saying between 1 and 4 or something like that, we say between a and a plus h. And that's going to present some challenges to us. So first let me get it kind of set up here, and then we'll talk about why it is we might care to do something like this. So to find the average rate of change, remember what we're going to do here is plug in one of the x values into the function and then subtract the other x value plugged into the function, all divided by that first x value minus that second x value. All right, now why would we do something like this? When you get into calculus, it turns out that you'll have this type of setup occurring a lot. And you'll have it for something that's called the derivative that you're going to learn about in calculus. And so this type of expression actually happens quite often. And in that calculus class, one of the things you're going to want to do is let this h get really, really close to 0. Okay? Now, that presents a problem here. If you let h go to 0, down on the bottom here, the a minus a cancel out to 0, and so the only thing you have left is h on the bottom. And we know that we don't ever want to divide by 0. So this whole premise of letting h go to 0 is actually problematic, but in calculus that's what you do all the time. All right, so what our goal is to try to see if we can simplify the top in such a way so that I can end up canceling an h in both top and bottom. And then sending h to 0 is not such a problem anymore. All right, so let's go ahead and plug this in. So remember, what this means is that you're putting a plus h in where you see x in the function. So this will be 3 times a plus h squared plus 1, and then minus f of a. So minus, and it's really important to put it in brackets or parentheses or something like that. Right? Minus a plugged into the function. All right, so as it stands, there's no way I can cancel this h out. So what I need to do is try to simplify the top best I can and see if there's, after simplifying, a way that I can actually do some nice canceling. All right, so the only thing that I can really try here is to just expand everything out. All right, so remember, whenever you have a plus h squared, whenever you have a binomial squared, you need to actually write it out, right? A plus h times itself and FOIL. All right, so we don't want to forget that. And while I'm at it here, we can distribute this minus sign, make sure it gets through to both of the terms. So we're going to have minus 3a squared minus 1. And so that's all divided by my h. All right. Still no clear way I can get this h to cancel. So let's go ahead and FOIL here. So I leave the 3 on the outside, and then inside these brackets I'm going to put the result of FOILing. So that'd be a squared, a times h plus a times h, it's plus 2ah, and then plus h squared. All right, but then I can also look up here and notice that I have this plus 1 and this minus 1, right? And so that gives me 0, so I guess I'm just left with minus 3a squared, all divided by h. Okay, now what I need to point out here is you must resist the temptation to start slashing out this h on the bottom with any of these h's up here. So remember that your rule is you cannot cancel terms, right? Remember that terms are things that are separated from each other by addition or subtraction. So you can't just pick out this h, cross it out, and then also cross it out on bottom. That's not allowed. The only way you can cross out a variable like that or a number is if it is factored out of everything on either the top or the bottom, whichever one you're looking at. All right, so I can't do anything with it right now. So I'm going to go ahead and distribute the 3 through to all of these terms to see if that helps. So we get 3a squared plus 6ah plus 3h squared minus 3a squared, all divided by h. Now this is really nice because we have a 3a squared and we have a minus 3a squared. So that gives us 0. And so everything that does not have an h in it goes away. And that's really good news because now I can factor a single h out of both terms on top. And that's what puts it in a position where I'm allowed to cancel out an h on top and an h on bottom because this h is being multiplied by everything else. So those can cancel out. And so my answer here is 6a plus 3h. So that was one example where there's kind of a lot of simplifying to do in the whole process. I want to show another example here where we've got to deal with fractions within fractions. So this one's asking me to find the average rate of change of this function between a and 1. So we have one letter, one number. So we know that what we're supposed to do is say g of a minus g of 1 divided by a minus 1. All right, so we can go ahead and start plugging things in. So I'm just going to plug a in everywhere I see an x. So a over a plus 1 minus, okay, now I'm going to plug a 1 in everywhere I see an x, 1 over 1 plus 1, all divided by a minus 1. Of course, this fraction I can do better with, right? A over a plus 1 minus 1/2 over a minus 1. But this is pretty ugly at this point, right? We got fractions within fractions, and we definitely do not have a simplified situation here when we have fractions within fractions. So I want to not have that anymore. So one of the tools you have at your disposal that you probably would have used in like your intermediate algebra class, but maybe it's been a little while since you've done this, is you can always multiply the top and the bottom by the least common denominator. Okay, so look at the denominators of all the fractions and ask yourself, what is the least common denominator? Well, if I look at a plus 1 and 2, they really have nothing in common with one another, right? So anytime you've got your two denominators with nothing in common, the LCD is just going to be the product of the two. So the LCD is just going to be 2 times a plus 1. And just to give an analogy here, you know, if I was to ask you to add 1/5 and 1/6, right? You would look at 5 and 6 and say, hey, they've got no common factor. So what's the LCD? The LCD is 30, right? And so you would make each of them have a 30 in the denominator. That's the same thing we're doing here. They have no obvious common factor, so just multiply them together to get your LCD. All right, so when I do that, I am then going to multiply on top by that LCD, but that's only legal if I also multiply on bottom by that LCD. Right? So on the top and the bottom of the big fraction, I'm multiplying by that least common denominator. So what happens is on top, it gets messy at first, but then it actually gets a lot better. So I can multiply this through. I'm going to have 2 times a plus 1, all divided by a plus 1. Well, you can see the a plus 1s are going to cancel, right? And now I have 2 times a plus 1, when I distribute to here, over 2. Well, I can see the 2's are going to cancel. Now I have kind of this mess on the bottom, but here's where I'd really encourage you to be as lazy as possible, because you might be able to cancel some things out on the bottom with what's on top. And if you are going to do that, you want it all factored anyway. So don't put yourself through more work by multiplying all this out. Just leave it exactly the way it is. Okay? Those cancel, those cancel. All right, so what I'm left with is, in the numerator, I've got 2a. And then let's be careful. This minus sign has to go through to both of these terms that are in parentheses, right? So it's minus a minus 1, all divided by this. And then I can clean up that numerator a little bit, so it's just a minus 1 over 2 times a plus 1 times a minus 1. And so you can see why it was so good that we left a minus 1 down here, because now I can see that it cancels out with the numerator, and if I would have multiplied stuff out down here, I wouldn't have seen that. So I go ahead and cancel, and then of course when you cancel everything from the top, what's really there still, of course, is a 1, right? So you have 1 over 2 times a plus 1. All right, so here's another one. This one's also another fraction example, and it has finding the average rate of change on the interval a to a plus h, so just like in example 1. All right, so now that you've seen a couple examples here, definitely pause this video and try this yourself and see if you can get it to a completely simplified state. All right, so I trust you've done that now. So let's see if we end up with the same thing. All right, so we're starting with this. So that's going to be 2 over a plus h plus 1 minus 2 over a plus 1, all divided by, well, the a and minus a canceled to just give me h. All right. So in the last problem, when we were at this point here, we go back. Remember, we were at the point of saying, okay, well, what's my, when I got two fractions subtracting with each other, I said, okay, well, what's my LCD? And I found it and I multiplied on top and bottom by it. So here we want to ask the same question, right? What's my LCD? Now, at first, this might be kind of a head scratcher because you're looking at this thing saying, boy, they really look similar, right? They both have an a plus 1 in them, but then this one has a plus h also, right? So do they have anything in common? Well, here's the key. What we're looking for is, do they have a common factor in them? And there's really no reason to think that they do, and here's why. Let's plug in some fake numbers here. Let's suppose that a is equal to 2 and h is equal to 1. So bear with me here. If a was 2 and h was 1, that would be 2 over 4, right? Would be that first fraction. And then if, remember, a was 2, that would be 2/3, right? So do these two denominators have anything in common? No, they don't have a common factor, right? Remember, factor means that you something you're multiplying, right? So there's no reason for me to assume that just because this is this one plus another h does not mean they have any kind of common factor. So I'm still going to do the trick of multiplying them by each other. And that ugly thing is my LCD. All right, so I'm going to go ahead and multiply on top by that. And on bottom by that. Now, it's really important that on top we don't rush to do too much work. just simply distribute this through. And by the way, when you're multiplying by this, you can think of it as that over 1, right? So that it's a fraction times a fraction. So that helps you kind of visualize better what's happening, then you can do that. So I'm going to have 2 times a plus h plus 1 times a plus 1 when that distributes through to here, all divided by a plus h plus 1 minus 2 times a plus h plus 1 times a plus 1 divided by a plus 1. And that's all divided by, and I'm really not going to be in a hurry to do any kind of multiplying out on the bottom because it just looks hard. And we know that maybe some of this will cancel. So, so there we just leave it just like that. But in the top I can see some nice canceling. This a plus h plus 1 is multiplied by everything in the numerator, so I can cross it out with that. A plus 1, same thing. So what I have now is 2 times a plus 1 minus 2 times a plus h plus 1 all over h times a plus h plus 1 times a plus 1. All right, we're just about there. We got to see if there's any kind of canceling or simplifying further that I can do. So I need to do some distributing up here to get things untrapped from where it is right now. So I have 2a plus 2, and then remember this minus 2's got to go through to everything. So minus 2a minus 2h minus 2. And you can already see some nice simplifying that can be done. So these, the 2 and minus 2, the 2a and minus 2a. So I'm left with just negative 2h divided by h, a plus h plus 1, and a plus 1. And then I can cancel those h's, and now I've got it simplified. Now, I really don't mean to scare us off from calculus. That's not my goal here. And when you get to this point in calculus, you're going to practice it a lot, okay? So it's okay if, you know, this is a little bit scary right now, but I do want you to know you will do this kind of thing. So I'm not just kind of torturing you here with some of this long drawn out algebra. So it'll take some practice, but you'll get some practice here in these class notes, and then also in the homework, you'll get a chance to practice some of these algebraic skills of yours.